So let's change to standard call and ask ourselves what happens in standard call. So in standard call, the parameters are also pushed onto the stack from right to left. Okay, so let's change this to standard call. Okay, and let's put our functions here. Let's move them a second into, and let's undo our standard call one. This is our standard call. It's the same function. It's exactly the same function, just as doing standard call. Okay, and we're going to take this function and not call it for a second, and let's run it again. Now this time it should run. You know what? Let's start from the name mangling part. So let's give it a name. Let's change this to character. And let's leave this back inside. Okay, and we'll make all this a comment. And let's see what the linker has to say. The linker is obviously going to give us an error, but notice this time our entry point must be defined, which means I'm missing the main somewhere. The problem was that we told the compiler in the properties behind the scenes that we'll show them in a minute to go and to use C declaration. So by calling the function main standard call, I actually couldn't find the starting position. I just erased the standard call quantifier and everything works. But if we take a look at the error list, notice that the names now look different. Again, if you take a look, it's actually two different types. The names are actually different. And that is due to the way that the call was actually being used. Now let's take a look at the runtime of it. Let's see how it looks in the runtime. So we'll copy that out and we'll erase this part. We'll move this back in. And we'll run it this time and we'll take a look at what the code looks like. So here's our code again. We're looking at this assembly. Very important for us currently. Notice again, parameters are being pushed from right to left. First B, then A, for the exact same reason, because we want them to show up correctly in the function. Now, very important is once the function is finished, notice that after the call, before we had an add. There is no add right now. So who's doing the add? So if we take a look at the function, let's go into the function and take a look at the function inside. Okay, here's our preamble. Here's our function y, x plus whatever. Now take a look what's going on here. This is our postamble. Notice that we have the pop, pop, pop. We have the move the EBP to the ESP, meaning moving down the ESP to the EBP. We pop the previous EBP environment. But notice the function now says return 8. Before, we didn't show it before in this segment. We saw before in the previous segment. It just said return. Now it says return 8. So that's actually causing the stack pointer to move back the 8 bytes. And if we move back to where we were, the stack pointer is going to be back at the location where it began at E8. Okay, which is exactly the location it began. It was at E8 and it still is at E8. So you see that the called function is the one doing the stack cleanup, not the calling function. Now, this has advantages and disadvantages. The advantage of the calling function doing the stack cleanup is because the calling function knows how many parameters actually passed. Now, you might say to yourself, well, the called function also knows how many arguments it received. Well, that's not really true because you are able to, there are functions out there like printf that are able to get a variable number of arguments. Now, a function like printf, the called function does not know in advance when it was compiled how many parameters it was going to get. The same thing is in C when you use the ellipsis, right? Int A, float B, dot, 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 the ellipsis. So you are able to actually pass a variable number of arguments. When you do that, the called function does not know in advance how many parameters is going to be passed, and therefore it cannot do the stack cleanup. So if you want to allow a variable number of arguments to functions, then the caller who knows how many parameters were passed is the one who has to do the cleanup. On the other hand, there is an advantage for the called function to do the cleanup. Notice that ret_n, for example, in our case it was return 8, is more efficient than ret and then add 8. Because ret_n is one assembly command, right? It just returns and moves the stack pointer. While if you do return and then you do add 8, well, that's 2 assembly commands and it's less efficient. So there are advantages and disadvantages to either one of these calling conventions. So we saw that they both pass parameters from right to left. We explained why. They both, in one, the caller does the cleanup. That's C declaration. In one, the called function does the cleanup. That's standard call. They have different name mangling rules in order to have a unique name, a unique identifier per function. So we've seen all that.